In this video, we will look at a problem of determining all possible letter combinations of a given phone number. If we remember from the past, there were there were phones which had numbers written from 0 to 9 on it, and on each number there were corresponding letters. Like if you type 2, yeah, you can write either of ABC, and on number 3 there are DEF, and similarly on number 9 wxyz were written. Now here the ask is, if the input is 2 3, that means if someone types 2 and 3 from that phone, so what are the possible combinations that can be generated? And here is the sample output that's given. So if we look closely, the first number is 2, so the all combinations will have the elements starting from the possible combinations of 2. So A B C. So here you can see that first three are starting with A, then with B, and then with C. And similarly, their combination is with the other element, which is 3. The correspondence of 3s are D, E, F. So A, D, A, E, A, F. And similarly, all rest of the combinations are also given. Now let's quickly look at the pseudocode of generating these combinations before jumping into the Java part. For our pseudocode, let's take the example of the same input array, which is 2 3. Now pick the first number. The first number is 2, so the correspondence of 2 are ABC. Let's write A here, B and C. Now for each correspondence, pick the next element. So the next elements are D. For the 3, the correspondence are D, E and F. And it will become AD, it will become AE, it will become AF. And similarly, for the next, we'll be doing the same procedure. DEF, and similarly I will be writing down for C as well. One thing we need to remember is that the solution we will be writing will be a recursive solution. So here we have stopped generating the combinations and have stored the result because there is no more element after 3. If there were another element, like in this output it's 4 to 6, so let's say here you had 4, so we would have written all the possible combinations that can be generated from 4, which is GHI, and then here is ADG, and for each element of the second index we have performed a similar kind of the iterations. Since it's a recursive solution, so we will see how we will be handling this inside the Java code. And before jumping into the Java code, we can quickly run an iteration where the total number of elements in the input is 3. So if our, let's say our input in this case is, let's say 568. So here is how the pseudocode will run. For 5 we have J, K and L, and for 6 we have M, N and O. And for 8, now for each M, for M we will be writing the combinations for 8, which is T, U and V. So it will become something like JMT, and this will become JMU, and this will become JMV. And similarly we can write the outputs for the others as well. For the Java part, I have written the basic skeleton. Here is the main method and here is the get all combinations method which we will be using. First thing we need in this get all combination method is a digit to letters map. I have already copied it so that we can save some of our time. This is an hash map so that against each digit we can get its corresponding letters. As discussed in our pseudocode, we know that we will be calling a recursive method, so let's call recursive method from here. Let's start writing the recursive method. We can name it get all combinations rec. Regarding the parameters of this recursive method, first thing we need is this array list of strings where we'll be storing our output. The next is this map which we will be using. Next is the input number which is given to us, numbers. We will need the index to keep track of the current element or the current number we are interested in, and at the end the current combination. Let's call it string builder combination. We've written a recursive method. Let's make call from this method as well, and from the string builder you can say new string builder. In the recursive method, our first step is getting each number from the input numbers at the current index. So let's say if input is 2 3, so this piece of code will return 2 to us, and then we will get all the possible letters against this number. Let's say string letters and number. Sorry, the name of our map is digit map. Digit map dot get number, and then we can iterate through all these letters. I'm using a for each loop. And in this for each loop we will start appending the current letter into the combination element, or sorry, combination variable. After appending, we will be making a recursive call with the next index, so this parameter will get changed to index plus 1, and at the end we will be deleting this appended element so that for the next iteration we can generate the correct combinations. Combination dot length -1. Now only one thing which is left is the base check, that when we need to stop. Since we are appending all the elements in combinations, so we need to check its length. When the length of the combination become equal to the length of our input, which is numbers dot length, that means that's the point where our path is of that length, and we can simply add it here, which will be combinations dot add, and we need to add the current combination dot to string, and that's it. We can simply try to return because this is the base case and we don't need to do anything in this case. Now let's try to run this code and see if it works well. I'm testing for the input 2 3. Let's run it. You can see that it has generated all the desired combinations which can be generated from 2 3 as we have seen in the input. Let's try to run it in some other input 4 5 6. So it will generate a lot of combinations, and for simply one variable which is 2, it will just generate the 3 combinations which can be generated from the number 2. So that's all. If you have any questions, you can ask me in the comment section. Thank you very much.